Myself, Justin Santhiyagu, Assistant Professor, Department of Electronics and Communication Systems. We are going to discuss about the subject digital and cellular communications, and the topic is data transmissions. Data transmission means process of transferring data between two or more devices. There are two types of data transmission such as analog and digitals. Analog and digital data transmission based on the three concepts: data, signals and transmission. Data means convey of messaging or informations. Signal means electromagnetic waves such as representation of data. Transmission means communication of data by the propagation and process of signals. Analog and digital data represented by the values, continuous values, zeros and triple nine. Digital data represented by the discrete value is also binary digit, zeros and 1. See the figures. And the representation of data signals. Data as well as signals that represent data can be either digital or analog. It's also based on the line coding. Line coding is the process of converting digital data to digital signals. It also can be divided into three categories: unipolar, polar and bipolar. There are three properties of line coding: overlapping and distribution of signals to avoiding, and more bits transmit on a single signals. Error detection is also done. There are long strings of ones and zeros to avoid to maintain transparency. Now we are going to discuss about that. Unipolar signals. Unipolar signals is also called as on and off keying. It also simply says OOK. The presence of pulse represent ones and absence of pulse zeros. There are two types of unipolar signaling: non-return to zero and return to zeros. See the figures. And unipolar non-to-return to zero means positive pulse called as mod, such as 1, symbol for between, and low data input has no pulse, and advantage and disadvantage. It's also simple and lesser bandwidth, and disadvantage: no error correction and presence of low frequency, no clock and loss of synchronization. Second one is return to zeros unipolars. It's also half of the bit duration high and half of the bit duration low. It's also called as single bit high, and low, no presence of bit is called as zeros. And advantages and disadvantages of unipolar return to zero: it's also simple spectral line. Disadvantage of unipolar return to zero: no correction, no error correction, and twice bandwidth, the single troop of the signals. There are two methods of polar signaling: polar non-return to zero, polar return to zero. First, polar non-return to zeros. High is data is represent positive pulse, low data is represented by the negative pulse. See the figures. And advantage of non-return to zero: it's also simple, low frequency components. Disadvantage of polar non-return to zeros: no error correction, no clock, and it's also 0 hertz. Polar return to zeros: it's the same similar pattern of the unipolar return to zeros. Half of the bit duration high and half of the duration is low. It's also called as pulse 1. Absence of pulse means zeros, low data. See the figures. And polar return to zeros advantages: simple and low frequency components. Disadvantage of polar return to zeros: no error correction, no clock is present, occupies twice of the bandwidth, and signal troop is zeros. And bipolar signalings: there are three voltage levels: positive and negative and zeros, such as duo binary signals also called as. It's also in the type of method is alternate mark inversion, that is short name for AMI. For 1 means positive to negative, from negative to positive. 0 means 0 voltage level. Bipolar non-return to zeros and bipolar return to zeros, can be divided into two types. See the figures. Advantages and disadvantages. Advantage: it's a simple, no low frequency components, no low bandwidth. This type of technique is also called as over AC coupled line. It's also single error detection method. Disadvantage, no clock, long sync of data causes loss of synchronizations. And pods and BPS. Pod is a measure of symbol rate. One of the component determine the speed of communication over a data channel. It is the unit for symbol rate and modulation rate are symbols per second. SPS or PPS. PPS stands for pulses per second. The term pod and BPS are often used interchangeably. The two are not at same at all. Data transfer rate is the amount of the digital data that is moved from one place to another in a given time. That is also speed of travel of given a time of amount of data from one place to another. That is called as data transfer rate. The DTR is usually expressed in bits per second. Next we are going to discuss about that serial and parallel transmissions. There are two methods in transmit data between digital data. Serial transmission and parallel transmission. Serial data transmission sends data bits one after another over a single channel. Parallel data transmission sends multiple bits at the same time. Serial communications can take many forms depending on the type of transmission mode and data transfer. There are three kind of transmission modes: simplex and half duplex and full duplex. And parallel communications. Parallel transmission several bits of data simultaneously using multiple lines. See the figures. There are comparison between the serial transmission, parallel transmissions. Data flows in bidirectionally bit by bit is also serial transmission. Parallel transmission, multiple lines are used to send data simultaneously. 8 bits are 1 bit, 1 byte at a time. And cost is low, and parallel transmission is also expensive. It's also clock pulse is 1 bit, that's clock pulse is 8 bits or 1 byte. Speed is serial transmission slow and parallel transmission is fast. Advantages: serial transmission cost effective and appropriate for long distance communication, more reliable. Parallel transmissions transmit data at highest speed, suit better for short distance communication. Set of bits are transferred simultaneously. And disadvantages: data transmission rate is low, throughput relies on the bit rate. Parallel transmission is costly transmission systems, and in order to transmit the data over long range, thickness of the wire has to be increased to diminish signal degradation. There are multiple communication channels required. Types of serial communication: synchronous and asynchronous. To identify the beginning end of the data transmission for bit synchronization. Bit synchronization is also support receiving computer to recognizing when data begins and ends during a transmission. Therefore, bit synchronization offer timing control. Asynchronous transmission is also data moves in of per approaching method, 1 byte or 1 character at a time. And see asynchronous transmission, data moves in completely paired approach in the form of chunk or frames. There are two type of comparison: synchronous transmission comparison, asynchronous transmission comparison. So it's also definition: transmit data in the form of chunk and frames. And asynchronous transmission, transmit 1 byte or character at a time. Speed of transmission: synchronous transmission is also quick, asynchronous transmission is low. Cost wise, synchronous transmission is expensive and asynchronous transmission is cost effective. Then time asynchronous transmission advantages, it's a easily constructed, it's a easily mechanical equipment, and it's facilitated manual operations. Disadvantages to tracking clocks, it's a quite sensitive distortions due to start and stop bits. Synchronous transmission is high efficiency and it's less sensitivity to distortions. Disadvantages, bit loss can make whole message errors. Special codes must be detected. Its equipment is cost. And the third one is 20 milliamps current loop. What is a 20 milliamps current loop? 20 milliamps current loop provides an effective means of providing serial data communication over long distance, typically using RS-232 protocols. Advantage of current loop: line losses. Line losses, it's based on the voltage losses. Long distance, it's based on the current loop systems. Isolated from ground. Isolated from ground is based on the voltage losses. And second, last one is simple networking. And disadvantage of current loop: no official standard, slow speed, convenience, signaling, and that's all. 20 milliamps line drivers. What is mean by 20 milliamps line drivers? It's also one of the electronic amplifier circuit designing for a driving load such as transmission line. The line drivers can be divided into two types: unbalanced line and balanced line. Balanced line subdivided into two types: single-ended operation and differential operations. Single-ended operation means simplest transmitting electric signals over wires. The main advantage of single-ended operation to transmit multiple signals. Disadvantage is cross-talking between the two devices. Differential operation to reduce the noise and connection by rejecting common mode interference. There are two categories: balanced line and unbalanced line. Next, we are going to discuss modem. Modem such as modulator and demodulator is also hardware device that's convert into data into format device. Modem are generally classified by the maximum amount of data that can be sent at a given unit of time. It's expressed by bits per symbol. Next, you see the figures. There are two type of method coupling modem. Indirect, it's also called as acoustic coupling, and second one is direct hookup coupling. Communication channels, there are three type of mode: communication transmission mode, simplex communication mode, off duplexing communication mode, full duplex communication mode. Simplex communication mode means it's only one direction communication. Off duplexing operation means bidirectional operation, but only one direction at any given time. Full duplexion operation, it is characterized by simultaneously bidirectional data transmissions. See the figures. Type of transient noise in digital transmissions. There are four type of transient noise. One is impulse noise, gain hits, drop outs, phase hits. Impulse noise is unwanted sharp sound. See the figures. Dropouts, signal decreases or signal losses the greater than that 12 decibels. Type of transient noise in digital transmissions. Transient noise means low frequency oscillation can be produced in pulse forward into channel interference for the unwanted signals. There are four type of transient noise: impulse noise, gain hits, dropouts, phase hits. Impulse noise means unwanted sharp sounds. See the figures. Dropouts, there are defined signal decreases or losses are greater than 12 decibels. See the figures. So phase shift, the pulse will be sudden changes in received signal phase and that frequency are lost for duration exceeding 4 milliseconds. See the figures. Gain hits, there are pulse, sudden rise or fall in the recent signal level that cause changes of less than 12 decibels. The phase shift. The phase shift means phase of the carrier signal result in pulses moving into time slot allocated for neighboring data pulse. There are different components are available. See the figures. Data signal, signaling shape and signaling speed. Input signal to a data system can be generally described as a pulse train of the form. Look at that equation. X of t, sum of k, t n and a of k, p of rho of t minus k of k divided by s. A k means amplitude level representing, and k means message digit, p of t that is rho of t, basic pulse shape with peak value, rho of value zeros and ones. 1 divided by a is pulse to pulse spacing. S means signaling speed. In ideal system, linear and distortionless overall frequency is based on the signaling speed and very short pulses. There are three following steps. One is frequency response, and second one is sinusoidal roll-off, and third one is raised cosine channel response. First one is frequency response of an ideal filters. It's based on the Nyquist first criteria. In order to minimize effect of the inter-symbol interference, by the properly timing pulse train. It's based on the sampling intervals. Second one is pulse and channel shaping. Two acceptable method solution used in raised cosine response and partially response encoding. Second one is sinusoidal roll off. In case of x of t is all 0 means one can signal synchronously at s equal to 2w. F1 should not 0 means the leading and trailing oscillation decay more rapidly means synchronization is less critical than with sine pulses. Third, F1 is W. First F1 is W can be divided into two categories of amplitude pulse width is exactly 1 by 2 with equal to pulse spacing. Second one is additional to zero crossing means negligible for inter-symbol interference for signaling speed is equal to less than 2 watts. Third one is raised cosine channel response. Another acceptable solution to problem communication channel in raised cosine channel response. First one is inter-symbol interference, second one is undershoot and overshoot errors, and third one is total bandwidth. Bandwidth is equal to with F positive F1 equal to 2 with when F1 equal to W divided by 2, the sinusoidal roll off is 50%. Therefore, signaling speed is 1.5 decibels. Two problem occurs. One is difficulty system response, second one is synchronization lost. It's generally, we conclude that S maximum is equal to KB. K is represented by 1 to 2. S maximum means maximum signaling speed. B is represented by the bandwidth. K is represented by the system design values. Conclusion. We conclude that in data transmission, there are two types of data signals such as analog and digital. There are three types of line coding such as unipolar, polar, bipolar, and there are three types of communication modes: simplex mode, off duplex mode, full duplex mode, and such as modems, bots, and PBS, signaling speed and shape mode. In this concept, we are implementing to the top communication channel. Thank you.